Welcome to another math problem of the week. For today's question, given that for each positive integer n, we define an to be equals to half 2 plus square root 3 to the power n plus 2 minus square root 3 to the power n. And it's known that an is a positive integer for each n. We are asked to find the remainder when A2023 is divided by 4. And the options are A0, B1, C2, and D3. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
We will provide two different methods here. So for method number 1, we are going to use binomial theorem. And since an equals to half 2 plus square root 3 to the power of n plus 2 minus square root 3 to the power of n, then it means that A2023 equals to half 2 plus square root 3 to the power of 2023 plus 2 minus square root 3 to the power of 2023. And this equals to half 2 to the power of 2023 plus 2023 choose 1 2 to the power of 2022 square root 3 plus 2023 choose 2 times 2 to the power of 2021 square root 3 square, and so forth until the last term will be square root 3 to the power of 2023. This is the expansion for 2 plus square root 3 to the power of 2023. For the expansion of 2 minus square root 3 to the power of 2023, it will be 2 to the power of 2023. For second term, it is negative 2023 choose 1 2 to the power of 2022 square root 3. And for the third term, it will be plus 2023 choose 2 2 to the power of 2021 square root 3 square. The last term, it will be a negative square root of 3 to the power of 2023. For the terms in the expansion, either they cancel off or become a double of it. So the remainder will be double divided by 2. So we have only 2 to the power of 2023 plus 2023 choose 2 2 to the power of 2021 and square root 3 square plus 2023 choose 4 2 2019 square root 3 to the power of 4, and for the last one should be 2023 choose 2022, and this will be 2 to the power 1 square root 3 to the power of 2022. Obviously, each of the term here is a multiple of 4 except for the last term. So it means that this is actually congruent to the last term, and for the last term is actually equals to 2023 times 2 times 3 to the power of 1011. And we note that 2023 is congruent to 3 mod 4 and 2 is congruent to 2 mod 4. 3 to the power of 1011 is congruent to negative 1 to the power of 1011, which is congruent to a negative 1, which is congruent to 3 mod 4. So this product will congruent to 3 times 2 times 3 mod 4, which will congruent to a negative 1 times 2 times a negative 1. And eventually this is congruent to 2 mod 4. And therefore the answer is C. And most of the responses that I received using this method 1. Now we go on the method 2. We will let alpha to be 2 plus square root of 3 and beta to be 2 minus square root of 3. And note that alpha plus beta equals to a 4, alpha beta equals to 1, meaning that alpha and beta are roots of the equation x squared minus 4x plus 1 equals to 0. Since alpha and beta are the roots of this equation, this will mean that alpha squared minus 4 alpha plus 1 is equal to 0. This also means that alpha to the power of n plus 2 minus 4 alpha n plus 1 plus alpha n equals to 0. Likewise, beta to the power of n plus 2 minus 4 beta n plus 1 plus beta to the power of n equals to 0. When we sum this up, we will have alpha n plus 2 plus beta n plus 2 plus alpha n plus beta n equals to 4 times alpha n plus 1 plus beta n plus 1. And we can multiply each of this by a half. Note that an is defined as half alpha n plus beta n. This means that an plus 2 plus an equals to 4 times an plus 1. Now consider a1. a1 equals to half 2 plus square root of 3 plus 2 minus square root of 3. And that is equals to half 4, that is 2, and it is congruent to 2 mod 4. For a2, we will need a little bit of calculation. So this is 2 plus square root of 3 square plus 2 minus square root of 3 square. So this will equals to a double of 2 square plus 3. So this will be equals to a 7, which is congruent to 3 mod 4. Using this relation, we know that a1 plus a3 is equal to 4a2, which means that it's congruent to 0 mod 4. Since a1 is 2 mod 4, so we have 2 plus a3 is congruent to 2 mod 4. And therefore a3 is congruent to negative 2, which is congruent to 2 mod 4. So using this relation and a bit of calculation, we can conclude that an is congruent to 2 mod 4 if n is odd. And we also know that a2 will be congruent to a6, will be congruent to a10, and so on and so forth, and is always congruent to 3 mod 4. And finally, a4 will be congruent to a8, will be congruent to a12, and so on and so forth, and it is congruent to 1 mod 4. 2023 is an odd number, and therefore a2023 will be congruent to 2 mod 4. And again, we get the same conclusion that C is our answer. And for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.